The potential of Plectranthus amboinicus essential oil as a repellent against Aedes aegypti mosquitoes. Dengue is one of the most important and fast-spreading vector-borne diseases in the tropical, subtropical and temperate regions. Majority of dengue infections are asymptomatic or manifested as mild fever. However, in some cases it is manifested as dengue hemorrhagic fever or dengue shock syndrome that can lead to death. In 2024, over 14 million dengue cases and over 10,000 dengue-related deaths were reported globally. Dengue cases in Malaysia, especially in Selangor, are consistently high. In 2024, a total of 122,423 cases and 117 deaths were reported in Malaysia, with Selangor leading the chart with 60,354 cases, or 49% of the total cases. Personal protective measures such as the use of mosquito repellents play an important role in preventing this disease. However, majority of commercially available mosquito repellents are formulated using synthetic chemical compounds. DEET is the most common chemical compound found in mosquito repellents. Unfortunately, DEET has been reported toxic towards children and elderly and cause damage to plastic and synthetic fibers. Mosquitoes are normally attracted and activated by a specific chemical or a blend of chemicals called pheromones. Some of potential human-specific pheromones that found to attract mosquitoes include carbon dioxide, lactic acid, sweat, and body odor. Repellents that are normally applied on the skin or clothing create an unpleasant condition for mosquitoes to land or feed, thus interrupting the human-mosquito contact. Essential oils obtained from plants have been considered one of the most promising alternatives to synthetic repellents. Many studies had reported the potential of plant derivatives such as aqueous extract or essential oils in controlling vector mosquitoes and proven to be more efficient than the synthetic chemicals. Plectranthus amboinicus is a perennial aromatic succulent shrub that belongs to Lamiaceae family that's commonly found in tropical and warm regions and is abundantly found in Malaysia. The stem and leaves of Plectranthus amboinicus plant are covered with fine granular hairs that secretes essential oil. The essential oil of Plectranthus amboinicus has diverse properties, including repellent activity. However, the potential of the essential oil as a mosquito repellent has not been explored fully. The main objective of this study is to evaluate the potential of Plectranthus amboinicus essential oil extracted from dried leaves using hydrodistillation method as a natural mosquito repellent in comparison to 10% DEET. The novelty of this study is it is conducted on human volunteers, compared to previous studies that were conducted using cotton or filter papers soaked in Plectranthus amboinicus essential oil. Conducting the test with human volunteers is essential as the host seeking and landing response in mosquitoes are influenced by chemical cues such as carbon dioxide, lactic acid, convection heat, and body moisture produced by the host. Plectranthus amboinicus leaves were collected from 4 locations around Hulu Langat district. The leaves were compared physically and thin layer chromatography was conducted to assure the samples were of similar chemotype. The leaves were then air dried, ground, and sieved to obtain 1 mm² size particles. The extraction of essential oil was carried out using a modified method based on British Pharmacopoeia 2022. 225 grams of dried samples were subjected to hydrodistillation using a Clevenger apparatus with 1:10 solid to solvent ratio for 6 hours. The distillate containing oil and water was collected and transferred to a separating funnel. The yellowish essential oil layer that formed at the top was separated and dried using anhydrous sodium sulfate. Dichloromethane was added to remaining aqueous layer to separate and collect any remaining essential oil in it. The essential oil was dried using 2 grams of anhydrous sodium sulfate. The anhydrous sodium sulfate was later filtered out and purified essential oil was stored in a 5 milliliter airtight vial at 4 degrees Celsius. Distillation was carried out 3 times using the same parameter. Each distillation was conducted in triplets. An average was calculated. An average of 0.76% essential oil was obtained. This is relatively high compared to previous studies. The essential oil was then diluted using ethanol to form a 10% test solution. The test solution was used to prepare the treated fabric and treated patch. 500 microliter of the test solution was used on each piece of fabric and patch, and the solution was allowed to seep into the fabric and patch for about 30 minutes before using them. The test mosquitoes were bred in the insectarium of Institute of Medical Research in Kuala Lumpur. 5 to 7 days old female mosquitoes were selected, starved overnight and employed for the test. 25 mosquitoes were released into each compartment of the test cage and left to acclimatize in the cage for 30 minutes. The control and treated arm were then introduced simultaneously into the cage through a circular opening, secured by netting. The number of mosquitoes landing in the confined area within 5 minutes was counted and recorded. This procedure was repeated every 30 minutes for 4 hours post-application. Each test was repeated thrice to get a mean value. The effectiveness of the test solution was determined by calculating the percentage of protection. The result shows that the mean number of mosquito landing drastically increased after 150 minutes when 10% DEET was used. However, the mean number of mosquito landing was almost zero throughout the test when the 10% essential oil treated fabric and patch was used. This shows that the percentage protection of 10% DEET decreases with time, while the 10% essential oil treated fabric and patch maintain the protection level throughout the test. The result indicates a significant difference between 10% essential oil treated patch and 10% DEET, and between 10% essential oil treated fabric and 10% DEET. However, there is no significant difference noted between essential oil treated patch and fabric. The bioefficacy test, conducted using 10% Plectranthus Amboinicus essential oil, tested in the form of treated fabric and treated patch, demonstrated a better repellent activity when compared to 10% DEET. Plectranthus Amboinicus essential oil treated patch shows the highest repellent activity against Aedes Aegypti compared to 10% Plectranthus Amboinicus essential oil treated fabric and 10% DEET.